Bonjour. Unfortunately, that's where the French stops, despite high school and my wife trying to convince me to learn French. A few more words than that, but not much. Right, so I'm going to talk about JDK 9 and really the future of Java, where we are today and where we're going in the near future and the far future. But let's start with a few questions for you, the audience. So, who here is using JDK 8 in production? Right, lots of people, good. Anybody using JDK 7? Few people. Anybody using JDK 6? Oh, okay, well you've got until the end of the year if you want some sort of commercial contract from Oracle, because they're going to stop support for JDK 6 at the end of this year. Right, who's using JDK 9? Ooh, a couple of people. 10? Okay, fine. So I'm going to explain quite a lot of things about how Java is changing, because there are some really significant changes that you need to be aware of in terms of JDK 9, JDK 10, and so on. Not just from a technical perspective, but also from the availability of updates and things like that. So let's move on. JDK 9. I'm sure most of you have already tried JDK 9 at least. Obviously you're still on JDK 8, but thinking about maybe migrating to JDK 9. JDK 9 was released in September of last year, and I borrowed this slide from Oracle. I used to work for them, so I figure they can lend me the odd slide here and there, which shows all the changes and new features that were added to JDK 9. So there are a lot, but of course the big one is the Java platform module system, modularity. And this has really changed the JDK in many ways. Over time, many APIs, many classes and methods have been added to the standard libraries. Back in JDK 1.0, there were about 200 classes in the standard libraries. In JDK 8, there's about 4,500. Now that's really good news for us because we don't have to write a list class, we don't have to write a semaphore class, and so on. But the problem has been that this has grown and grown as a monolithic library. And what we really wanted to be able to do is break it up into manageable pieces so that when you wanted to distribute your application, potentially with its own runtime, you could only ship the modules that you needed rather than having to include all of the things you don't need. So what the module system has done is to take rt.jar and do away with it. We now have, in the case of the Oracle JDK, 97 modules, of which 28 are the Java SE standard, as defined by the JSR. There's 8 for Java FX, there's 59 which are JDK specific, and there's 2 which are Oracle specific. The other thing that modularity did is to at least propose the idea of encapsulating all of the internal APIs. And these are the ones which are there to make the public APIs work. But as developers, you have always been told, do not use them. And Oracle have been, and Sun before them, have been very explicit about this, saying these internal APIs are not supported in the sense they may be removed without notice, they are not documented, and so on. So let's have a show of hands again. Who here has used sun.misc.Unsafe? Okay, a few hands. Who uses a third-party library or framework, like Spring or something like that? Yes, so you probably use sun.misc.Unsafe, you just don't know about it. So the important thing is that Oracle wanted to encapsulate all of those APIs. They wanted to make sure that you couldn't use them anymore. But clearly that was going to break a lot of code and break backwards compatibility. So they decided that they wouldn't actually enforce this, and they'd give you some command line options that would allow you to override access to these APIs. And so there is this wonderful big kill switch command line flag that you can use, and you can do it in a more specific way. You can turn on access to APIs either through importing or through reflection. So there are ways around this. Now, the important thing is compatibility. As I say, Sun and Oracle have always been very concerned about making sure that if you have a Java application that runs on version N, that it should run on version N+1 without any changes. This is very nice because it means you as developers don't have to take a working application and then change it to make it work on a new version of the platform, because you're just wasting time in effect. And so I've taken this quote from Sun's product management, who said, clean applications that just depend on java.se should just work. it's a little less than encouraging when they say should just not work, or should work, not will work, which is what you're really looking for. And they've been very precise in the language that they've used there, because JDK 9 has taken a big step in terms of how the JDK is developed. Now, obviously, lots of new features, modularity, and so on. But the other thing that they've done with JDK 9 is start removing things. Now, this actually makes sense, because if you go back in the history of Java, right from 1.1, we've had the deprecated tag, and things have been deprecated. But until JDK 9, not a single thing that had been deprecated had been removed. And clearly, Java is now sort of 23 years old, so lots of things have been added over time, and some of them were added way back in the sort of mists of IT history, and they're not really relevant anymore. So it's actually very logical to start doing a bit of housekeeping, cleaning up and removing some of the things that aren't really being used anymore. But that is potentially a problem, because it could break backwards compatibility for existing applications. And in fact, I'm going to do a talk tomorrow where I'm going to go through all of the things in JDK 9 and JDK 10 which could potentially break your code when you're moving it to that platform. So one of the things that you need to be aware of with JDK 9 is missing modules. We have a module system, and if you remember that previous slide, clean applications that only use java.se. Now, java.se is a meta module. It's a module that doesn't include any packages, it just references other modules. And then there's another meta module, which is java.se.ee, just to be slightly confusing. And that includes a number of things which, again, have been added over time and were obviously related to more the enterprise side of Java. And so what happens now is that if you use the java.se.ee modules, these are not included by default, which means that if you compile code against them, or if you try and run code against them, then you will get an error. So you won't be able to compile, you won't be able to run your application. You can turn them back on again, so you can say, I do want these modules, and you can compile your code and you can run it. But what's going to happen in the future is that they are going to be removed, and we'll talk about that in a few moments' time. The modules that are affected are Corba. Anybody here using Corba? Okay, you two, out of luck. But most people are not using Corba because it's an old technology, and clearly I don't think anybody actually developing new applications using Java, or using Corba. No. Okay, so Corba is one thing that's going away. Transactions, activation, XML type APIs, which are related more to the sort of older way of doing web services. These are specifically around the SOAP-based web services. Anybody using SOAP-based web services? Okay. Oh, a few people. Okay, so this is something that might affect you in later versions of Java. Like I say, in JDK 9 you can still use them, but moving forward they are going to disappear. So these are the kinds of things that you need to be aware of when you're thinking about moving to JDK 9 or JDK 10 or potentially JDK 11, because all these things are still going to be affecting you. Right, so the next thing to talk about is what Oracle have said about moving Java forward faster. And before Java 1 last year, there were a number of announcements that were made about how the JDK was going to be developed as we move into the future. The first of these was there was going to be a new release cadence for the JDK itself. And the idea is that rather than moving from the sort of rather slow way that we've had of developing the JDK in the past, we're going to have a much faster way of developing the JDK. So there will be 2 releases of the JDK every year. So that's 1 release every 6 months. JDK 9 came out in September of last year. JDK 10 came out in March this year. JDK 11 will come out in September, and then next year we'll have 12 and 13, next year we'll have 14 and 15, and so on. So this is a very different way of developing the JDK. If you look at the ideas behind this, it's really about making the development of Java, the platform, more agile, because the rate at which we've been able to get hold of new features has been very slow. I mean, if you take the example of moving from JDK 8 to JDK 9, originally the JDK engineers had said, we want to release a new JDK every 2 years. And that hadn't really worked out because it was literally 3.5 years between JDK 8 and JDK 9. So even if you wanted small changes, you had to wait a long time for them. So what Oracle want to do is to move the Java platform forward more quickly. Developers can get access to features as they're ready, and you get a better experience in terms of development. So the way this is going to work is, in the past, the idea has been that at the beginning of a JDK development, ideas have been put forward and people decide, right, so we're going to put feature X, feature Y into this release. When they're ready, they release the JDK. That means delays if a new feature isn't finished, which is a good example of the module system because it took longer than they thought, so they had to delay the release of JDK 9. Rather than doing it that way, what they're going to say is have a time-based release, which means that whatever is ready in March comes out with that JDK. Whatever's ready in September comes out with that JDK. If a feature isn't ready, you delay it to a later release, whether it's the next one or the one after or whenever. But it means that you can keep up with a consistent release for your JDKs. What this has sort of led to is a new version numbering scheme. And I wrote a blog about this because it's quite interesting. We've had many versions of Java, and we've had almost as many numbering schemes for the version of Java as we've had versions of Java. So, of course, we started off very logically with JDK 1.0. Then we had JDK 1.1, which really should have been called JDK 2. But then, of course, marketing got involved, so we had Java SE2 version 1.3. And 1.4, 1.4.2, and then they dropped the 1, so it was Java 2 SE5. Then it was Java 2 SE6, 7, 8. Okay, so that was starting to get more logical. But engineering was still involved, so if you did Java minus version, you'd see it was version 1.8.0 underscore update whatever. To simplify that, we've been through a few more iterations of the version numbering scheme, and now they've come up with this, the hopefully final version numbering scheme for Java, which will be 4 numbers separated by periods. First number is feature, so that's the big number, 9, 10, 11, and so on. Okay, that's logical. Next number is what they call the interim number. It used to be what they called minor, and they've decided that this was always going to be 0. Okay, so if it's always going to be 0, why put it there? But they're reserving that for future use in case they need another number. So actually, it kind of makes sense. Then there's going to be an update number, which also is more logical now, because if you look at JDK 9, which used the sort of slightly newer, older version of the version numbering scheme, you had 9.0.1 as the first update. The second update, which you would expect to be 9.0.2, was 9.0.4. Okay, now, when I count, 1, 2, not 1, 4. There was some sort of logic to that because they left 2 numbers in between in case they had to release an emergency patch between those. Now they have update, which will increment 1 at a time, and then if they have to issue an emergency update, it'll be .patch, so .1, .2, and so on. Great, so now we have a clear version numbering scheme that should work in the future. Next thing, availability of updates to the JDK. So this is something that has been issued all through the history of Java. We have our major release, and then there are updates to fix security things and bug fixes and so on. What Oracle have said is they're moving to the idea of a long-term support model. So there will be a long-term support release every 3 years. And this is because with a new release every 6 months, it's very difficult to have long-term support for all of those releases. So they're going to say, okay, every 3 years we will have one of our releases, it'll be a long-term support release, and we will then deal with that as a particular release. JDK 8 has been deemed a long-term support release. This is very logical because it's the current release, and so they need to sort of synchronize with this new model. The next long-term support release is going to be JDK 11, which is why JDK 9 no longer has any updates. JDK 10 was released last month, so at that point, updates to JDK 9 stopped. JDK 10 will have updates until JDK 11 comes out, and then updates will stop. Okay. Next thing, a tale of 2 binaries. Now, this is again a change that Oracle have made in the last 6 months or so. In the past, if you wanted to get a free version of the JDK, you would go to java.oracle.com or java.sun.com before that, and you could download the JDK from there. In order to do so, you would need to accept the terms of the Oracle binary code license, and that has certain restrictions. There's this thing called the field of use restriction, which means you can't use it in embedded applications without a license. So if you're using it for desktops, if you're using it for servers, it's free, but not for embedded applications. What Oracle have recently decided is they're going to provide another binary. And this is the OpenJDK binary. So what they're doing is they're taking the OpenJDK source code and they're building that and creating a binary distribution from that. This is being released under a different license. So it's being released under the more permissive GPL v2 license with the class path exception, which means that you don't have to worry about the viral nature of the GPL license when you're using an application and having to ship the source code to your application as well. So there's no restrictions in terms of how you can use that in terms of field of use. The thing with the OpenJDK binaries is that they are only going to have security and bug fix updates for 6 months. So all of the JDKs that are released are only going to have updates for 6 months. When the next one comes out, updates to the previous one will stop. So currently, there are 2 scheduled releases for each of these. So JDK 9 had 2 updates, JDK 10 will have 2 updates. Maybe if there's an emergency, they'll issue a 3rd one or a 4th one, but the idea is there will only be 2 updates for each JDK. The other important thing is, unlike what we're used to, there will be no overlap of updates between releases. I'll talk more about that in a moment as well. Oracle binaries. What Oracle have decided is that they want to reduce the number of platforms that they support. Now, this makes sense because they have commercial implications in terms of how many people they need to hire to do all the work. So what they've said is that from JDK 9 onwards, there will be no 32-bit binaries, so no Windows 32-bit, no Linux 32-bit. They're not supporting the ARM platform anymore, so they've moved away from the idea of embedded applications or even ARM 64-bit. The only platforms that they will make Oracle binaries available for is Windows, Linux, Mac, and Solaris Spark, all of which will be 64-bit only. So this is very much targeted at desktops and servers and the cloud. Oracle have also said that they want to open source more things that they had as closed source. And the 2 really kind of significant things here are Flight Recorder and Mission Control. So these have been available. You can use them in development for free, but if you wanted to use them in a production system, then you would need to sign a license with Oracle and pay them some money. Oracle have said, moving forward, that they want to make those open source, and they will include them into the OpenJDK project, which is really nice because then it means you can build them from source or you can get somebody else to do it, and then you can use them without any restrictions. So this is good. There's a couple of other things that are going into the OpenJDK project. There's things like application data class sharing. There's some certificate type things as well. The goal of open sourcing these things is to have no functional difference between the binary that you can build purely from the OpenJDK source and the Oracle JDK binary. Because at the moment, if you look at what you get in the Oracle binary, you've got things like Mission Control and Flight Recorder. You've also got things like the browser plugin. You've got WebStart, JavaFX, various things like that. So the goal is that there will be no functional difference between an OpenJDK binary and the Oracle JDK binary. Now, let's eliminate some confusion, because a lot of people I've spoken to, a lot of customers I've spoken to, get confused about what some of these things mean. So the first thing is that Oracle have said there will be an LTS release every 3 years. Fine, but this does not mean that you will get 3 years of free updates. And that's something that a lot of people seem to think. JDK 11, they think, is going to have free updates for 3 years. No, it's not. LTS release from JDK 11 onwards will only be available to commercial support customers of Oracle. So this is the Oracle binary. If you want 3 years or more of updates, then you will need a support contract from Oracle or from somebody else. The only free JDK after 11, or 11 and onwards, is going to be the OpenJDK binaries. You will still be able to download the Oracle JDK binaries, but you will not be able to use them and deploy them in production without a license for support from Oracle. And they've actually said this. You know, there are various things that they put on their website that say this. So if you want to continue to use Java for free with updates moving forward after JDK 11, then you will have to update your JDK every 6 months. That's quite a big step. So there's no more overlap of updates. This is very important. If you want to keep up to date with security fixes, you will need to change the JDK every 6 months. So take some time to think about that and how it will impact your business, how it will impact your use of Java. This is already starting to change. This is, if you update Java right now on the desktop, this is the sign that you're going to get from the update program. And it says that, it actually makes it clear that as of January next year, there are going to be some changes in terms of how Java updates are made available. What Oracle have said is that for desktop users, non-commercial desktop users, so if you're a home user or whatever, that's fine, you will be able to still get updates for Java 8 moving forward. But if you're a commercial user, things are going to change in January next year. This again is a slide that is from Oracle, and it's a bit of an eye chart, so I'm not going to expect you to read it, but it shows the reality of what's happening. So if I zoom in on a couple of bits here, essentially what they're saying is that the green bar in the previous slide shows the OpenJDK binaries. And these are the free ones. So you will get update 11.0.2, and then the next version of that will be version 12. There will be no 11.0.3 as an OpenJDK binary. So this is why I say that this idea that you have 3 years of LTS release, no, it's only 6 months for the free OpenJDK version. 11.0.3 is only for customers of the Oracle binary who pay for support. Right, let's talk about the future then, or actually not quite the future. Let's talk about JDK 10, because that just came out. What did we get in JDK 10? Well, first of all, we got a JSR, which is good because we wanted to do the whole development process in the same way. And so there was JSR 383. This is led by Brian Goetz. There is an expert group that was formed for that with most of the usual people there. So there's Oracle, IBM, Red Hat, SAP, and Azul. So I'm actually on the expert group for JDK 10 and 11 and so on. JDK 10 was released on the 18th of March, so last month. And the good thing is that proves that the 6-month release cadence does work. And again, I went through all of the details of JDK 10, and I found that there were actually 109 new features and APIs, which is quite impressive when you think there's only 6 months of development there. There's actually quite a lot of different things that went in there. In terms of features that went in, probably the biggest thing which is a change for developers is the introduction of local variable type inference, which means now Java gets the keyword, well, not actually the keyword, Java gets the use of var. If you've got something simple like this, you can say var list equals new array list of type string, and the compiler will infer that the list reference is going to be of array list of type string. Great. And if you generate a stream from that, the compiler will infer that the stream is of type string. Better example, maybe, map string list of big decimal equals new hash map. You can change that to var m equals new hash map string list of big decimal. A lot of these things, you know, they're fairly small changes, but it's designed to reduce the verbosity of Java. There are some style guidelines. If you go onto the OpenJDK website, Stuart Marks has written a nice set of guidelines for where to use var. Essentially, the way I look at it is you definitely want to, the place where I would use var is if you're assigning something to a variable, but maybe not so much if you're trying to get a reference from something. So in the first set of examples, var list is good, var stream maybe not so good. Other things that were included in JDK 10, parallel full GC for G1. Okay, that was kind of interesting. It was designed to improve the performance of the G1 garbage collector because the parallel collector seemed to work better, so they've added a full GC part to that. Application class data sharing was another JEP. This was, again, a previous commercial feature that Oracle had. So this is the idea of having the ability to know functional differences between the two JDKs. Experimental-based, Java-based JIT compiler, Graal. There was an announcement yesterday about the Graal VM. The Graal JIT compiler is sort of part of that, so that it can do different things in terms of the way that the JIT works. Root certificate inclusion. This, again, is the idea of eliminating differences between JDKs, and a fairly small thing, which was consolidating the JDK repos forests into one rather than having 8. A few other things, heap allocation on alternate devices. This is so that you can split your heap across volatile RAM and non-volatile RAM if you want to. Remove the Java H tool, so you can do Java C minus H now, and it'll do the same thing. There's a garbage collector interface, which is internal to the JVM, so it's not one that you can access from Java code. It's designed so that for, well, people like us, where we change the garbage collector, it becomes an easier job in terms of integrating a new one. And there's a low-level feature around thread local handshakes, which is designed to improve performance where you want to pause a single thread and not having to get to a global VM save point. A few new APIs. As I say, I counted up, there were 73 new ones in JDK 10. Some interesting ones. There's some nice ones around collections, specifically around unmodifiable or immutable collections. So there are static methods on list, set, and map, which will do a copy of a collection and create an unmodifiable collection. Optional gets or else throw, which is kind of like get, just a slightly different way of doing it. And there are collectors related to unmodifiable collections so that you can collect into an unmodifiable list, map, or set. A few miscellaneous things in JDK 10. XML input factory new factory method was deprecated in JDK 9, and they realized that was a mistake. So they have now, well, I'm not sure, did they undeprecate, did they de-deprecate, or did they precate it? But anyway, they've removed the deprecated tag from that particular API. The auth package was removed, so that's 6 deprecated classes that were removed completely. Also, the security manager, 1 deprecated field and 7 methods were removed. And one of the nice things in JDK 10 is it now is more container Docker aware in terms of understanding that the container has a limitation on CPU count and memory, and it uses those when it's identifying sizes of things like the fork join pool and the heap if you don't specify it explicitly. JDK 11 is coming. It's going to be here in 5 months' time. So what things are already in the, or on the list for JDK 11? Well, in terms of the specification, there is a new JSR, same spec lead, same expert group. And the idea is that in the future we'll be having more of a rolling JSR rather than having to create a new one every time. That requires some changes to the JCP process. That needs to be done before we can actually sort that out, but that will happen at some point. There is early draft review of the specification available, and there are builds available of JDK 11, so you can try that out. Scheduled for release on 25th of September, and as I say, this has been designated as an LTS release, which is only for commercial customers. Current JEPs for JDK 11, obviously there may be some more. This is the current list. Dynamic class file constants. This is the idea of taking the same approach that we did in JDK 7 with the introduction of the invoke dynamic bytecode. Invoke dynamic was put there to make it easier for people who were developing languages other than Java that were being compiled into bytecodes. And so if you're using a dynamically typed language, the performance you got on the JVM was not so good in terms of things like method dispatch. So invoke dynamic was the idea of moving from compile time resolution to runtime resolution and making it easier to do that so that dynamically typed languages would work better on the JVM. This is another thing which is designed to help language developers and compiler writers to get better performance out of the JVM with other languages. So it's about how the constant pool within the JVM is used and again, moving things from compile time to runtime. There is a new garbage collector in JDK 11, the epsilon garbage collector, which doesn't collect garbage. It's kind of an interesting idea. So if it doesn't collect garbage collector, how is it a garbage collector? The idea behind this is actually more for people who are developing garbage collectors to be able to evaluate what the performance impact of their garbage collector is. So what you do is you enable epsilon garbage collector, run an application, presumably it was not going to run out of memory, so you run it for a while and you see the performance level of that, do some benchmarking, then you turn your garbage collector on and run the same thing and you see what the impact of your garbage collector is on that. There are some people who believe that they can use epsilon in production. I'm kind of a little wary about that, but theoretically, if you're not going to run out of memory, you could do it, but best of luck with that. Other things, the Corba and Java EE modules, so the java.se.ee meta module is being removed in JDK 11. So if you're relying on these things, JDK 11 is taking them away. HTTP client, this is providing support for HTTP2. That was an incubating module in JDK 9 with the idea that people could try out the API, give feedback, see if there were things that needed to be changed before it made part of the standard. Now that that's happened, it is going to be made part of the standard. Another thing is JEP 323, which is including local variable syntax for Lambda parameters. I'm not totally convinced by this because it seems a bit superfluous to me, because at the moment, Lambda expressions have type inference. So you don't actually have to specify the type of a variable in a Lambda expression. So you can simply say x, y, x.process y. Great. But they've decided that they will allow you to, if you really want to, specify var. And then it will also do local variable type inference for the parameters of your Lambda expression. Why you'd want to, I don't know, but apparently now you can. There are currently 36 new APIs in JDK 11. A couple of things here that I sort of picked out as ones that might be interesting. So input stream, you can now get a null input stream from which you can read nothing. Okay, not sure how much useful that is. I'm sure there are places where you'd want to use that. Similarly, a null writer, you can throw as many things at it as you like and nothing will happen. The one that I did find that might be useful is path of, which allows you to create a path. There's a static method there, and so you can specify a series of strings and generate a path from that. Hopefully there will be some other ones as well. Longer term, JDK futures. Okay, there are a whole set of projects that the OpenJDK has looking at sort of further reaching ideas, because with the 6-month release cycle, sure, there's small ideas that are coming, but what about the bigger things? And so these are broken up into projects. There's Amber, Valhalla, Loom, Metropolis, and Panama are the sort of main ones, and I'll just spend a few minutes talking about those. So Project Amber is really about looking at how to simplify Java syntax. We're familiar with the fact that Java can be a bit verbose in places. You end up with a lot of boilerplate code, especially if you compare it to Kotlin at the moment. Kotlin allows you to have a lot more succinct ways of specifying things than you can sometimes in Java. So a couple of these things have already been either made it into the JDK or will very shortly. So local variable type inference made it into JDK 10. The local variable syntax for lambdas is going to be in JDK 11. But there are some other ideas. So one of them is enhanced enumerations. So enumerations are in effect a type of class. So what they're going to allow you to do is to have a type parameter, so make it generic, so that you can have type parameters associated with an enumeration. That's one idea. That's not so much reducing the boilerplate code as actually making it more. There's some Lambda, what they call Lambda leftovers. There's a few things that they were going to do in Lambdas, but they didn't get around to, so they're going to add them in later releases. One of those is the use of an underscore. In JDK 10, was it? Or was it 9? Whichever. One of them, they said that the JDK, the underscore, was now going to be a reserved word. Strange. But you couldn't use it as a variable name. Anybody here use a single underscore as a variable name? Oh, okay, well, you can still use 2 or more underscores as a variable name, and that will work. But the idea now is that with a Lambda expression, if you have a parameter for your Lambda expression which is not used in the body of the Lambda expression, then you can use a single underscore to sort of make it obvious that that parameter is not being used. Raw string literals, this is an interesting thing. I was actually spent some time over lunch talking to people and discussing this. So the idea is now you'll be able to use a back quote, and then anything that follows that back quote will be interpreted as a string. And then you can put spaces in there, you can put backslashes in there, you can put new lines in there, and it will all be interpreted as a string. Of course, you then have to ask yourself, well, what if I put a back quote in there? Isn't that going to be a problem because then I have to escape the back quote? Aha. Apparently, you can use more than one back quote to start your string. So if you start the string with 2 back quotes, then if you put a single back quote in the string, it's not interpreted as the end of that string. And you could have 3 or 4 if you wanted to. So it has a lot of potential for interesting code, I think. Pattern matching. This is JEP 305. This is extending the way that the switch statement works. At the moment, you can switch on strings, you can switch on values. That's all good. Now, what you'll be able to do is switch on types as well. So if you wanted to basically test against a type of a variable and do something specific, at the moment, you need a very complex if-else using instance of, and it would be very verbose. Now, with JEP 305, the idea is you'll be able to specify a case which is a type and then do something specific to that. Another thing in terms of switch statements is the idea of switch expressions. And this kind of thing is something that you often find happens with a switch statement. It's not always, but it's a very common use of a switch statement, is that you want to take a particular value and then do something and assign a value based on the first value. So in this case, what we're saying is look at this day and then see how many letters there are in that day and assign a value based on that. So Monday, Friday, Sunday, number of letters is 6, Tuesday it's 7, Thursday, Saturday it's 8, Wednesday it's 9. Great. But obviously, lots of lines of code there. So the idea of switch expressions is to sort of borrow some of the syntax from Lambda expressions and allow you to, in effect, return a result from a switch statement. So now what you'll be able to say is num letters equals switch on day, and then you can say case Monday, Friday, Sunday, using comma-separated values rather than having to have a separate line, separate case statement for each. And then the value that will be returned for that will be 6. Similarly, for Tuesday, it'll be 7, Thursday, Saturday, 8, Wednesday, 9. So that means that the value returned from the switch statement will be explicit based on the individual cases. Obviously, in our example on the previous slide, we had an exception that was thrown if we had something that was anything other than those values, so the default. And you can still do that in terms of the code. So you can say, in the case of default, don't return a value, but throw an exception to say that that wasn't a valid value to process. Project Valhalla. So this is something that's been going on for a while now, and is the idea of how to improve the performance of Java code. Because in the initial design of Java, originally it was thought, well, let's make it a truly object-oriented language and have everything being an object. But what they discovered was that performance wasn't going to work if we treated everything as an object. So we have primitives to give us better performance. Primitives performance objects for object orientation, so encapsulation, polymorphism, inheritance, and so on. Problem is that we can't use primitives in certain situations. So generics is a good example. So we can't do an array list of int. We have to do an array list of integer, the wrapper class. And that has a whole overhead in terms of having to create objects, box the value, garbage collection overhead, unboxing the value, and all things like that. So it's not an optimal way of doing things. So Project Valhalla is looking at how we can do that and have an array list of int and make it work. The other thing is the idea of value types. So an object which has a fixed value so that you can reference it without having to create, if you want more than one of them, you don't have to create a new instance of that type. You simply reference the same value. It's the idea of it codes like a class, works like a primitive. So it's like thinking, well, okay, 3 is 3. So however you refer to 3, it's the same 3. and that would be the idea of the object. So treat it like a class, so it can have methods, it can have fields, it can implement interfaces, it can use encapsulation, it can even be generic, but you can't mutate it, and that really means it's more than just final. It's really, really final. So there's no reflective access that will get you around that. And it can't be subclassed because of that. Project Loom. This is another project that's looking at how to improve concurrent programming and making it simpler. Problem we have is that in massively multi-threaded applications where you're doing things like a web server where you want to have literally thousands, tens of thousands, even millions of connections, threads are too heavyweight. So we need a lighter weight approach to that. Project Loom is going to introduce the concept of fibers. JVM level threads. If you can remember way back in the history of Java, this is like green threads, which are threads that are implemented at the JVM level rather than at the operating system level. The idea of fibers consists of two parts. One is a scheduler, one is a continuation. Continuation is just simply the flow of instructions that you need to process. So they're going to use the fork join pull scheduler that's already there, and then add continuations as a separate thing to the JVM. Idea is that, as I say, lighter weight threads rather than the operating system threads, less use of memory, and pretty much zero overhead in terms of task switching. Project Metropolis. This is the idea of rewriting the JVM in Java, which is kind of interesting because then you think, well, okay, if I rewrite the JVM in Java, don't I need a JVM to run the JVM? And then you kind of get into this hall of mirrors idea. Well, no, actually, it's not quite as silly as that. Because what you can do is you can take the Java code and compile it using an AOT compiler to native instructions. And then you can run that without the use of a JVM. But then you can also use a JIT, so the Graal JIT, for example, to optimize the JVM as it's running. So there's a lot of interesting ideas there, a lot of quite significant challenges as well. And we'll see whether that actually comes to fruition at some point in the future. But that's one of those longer term projects which nobody's saying, oh, JDK 12 is going to be completely rewritten in Java. No, that's going to be somewhere in the future. Briefly mention the fact that, because I work for Azul, so we have Zulu Java, so I might as well mention that. So this is essentially what we do in terms of creating a binary from OpenJDK. We compile just the OpenJDK, then we run the TCK on it to make sure it passes all of the tests, and we can guarantee that it is a conforming Java SE implementation. We have versions of 6, 7, 8, 9, and 10 available, and clearly when 11 comes out, we will have that as well. We also have wider platform support, so you can get 32-bit Windows, 32-bit Linux, ARM 32, 64-bit, and even PowerPC. And all of that is completely free, which is great. And if you're interested in a commercial support contract, we will very happily talk to you about that. So, to summarize, since I'm actually doing very well in terms of keeping within the time, so Java continues to move forward. There are some quite significant changes, not just from a technical perspective, but as I say, the new release cadence, new release every 6 months, quicker access to new features is great. Be aware that from JDK 11 onwards, there are some issues around if you want updates to your JDK and how you're going to be able to get access to those. Lots of good ideas for how to improve Java further, value types, fibers, Graal, all those sorts of things, and lots of other smaller things as well. There's lots of, if you look at the list of JEPs, they're continuing to add new, smaller features as well. So like I say, this is really kind of helping to keep Java the most popular development platform on the planet. And with that, thank you very much. Merci beaucoup. Oh, we actually have time for questions. There's a question at the front.
One quick, small question.
I think I have one question time.
Hello. You didn't mention the ZGC, which was supposed to, unless I missed it, which was supposed to be shipped with Java 10. What happened with it?
No, ZGC, or ZGC, as the Americans like to refer to it, is the zero garbage collector. This is designed as a very low pause collector. It's actually very similar to what we do at Azul with Zing in terms of the way that it works. No, it is very much still an experimental project. It's a project in the OpenJDK, but they haven't specified any delivery date on that. So that is not scheduled for JDK 10 at all at the moment. Nobody has said anything about when it will be shipped. In fact, I think they just came out literally either today or yesterday with a sort of second release of the sort of early access to that.
Okay. Thanks.
Okay.
Yeah. Thanks, Simon.
Merci.